This N. Malathi, working as an assistant professor in the Department of Mathematics, V. Varniyaperumal College for Women, Virudhunagar. In this video, we are going to see about the matrix representation of a graph. First of all, let us see about the graph. A graph consists of a pair V, E, where V is a non-empty finite set whose elements are called the vertices or points, and capital E is the set of unordered pairs of distinct elements of V which are known as edges or lines. Let us see an example. Here this is a graph with the points A, B, C, D, E. These 5 points are said to be the vertices, and the lines connecting two distinct points AB, AC, CD, BD and DE are called the edges. So this graph is having 5 vertices and 5 edges. In simple way, we may say that this is a 5,5 graph. Now let us see about the matrix representation of a graph. So first of all, we are going to see about adjacency matrix. If we consider a graph with P vertices and Q edges, the P cross P matrix is said to be the adjacency matrix of the given graph if the entries A, I, J is nothing but 1 if the vertices Vi and Vj are adjacent, and 0 if they are non-adjacent. Let us see an example. This is a graph with 5 vertices and 5 edges. Let us find the adjacency matrix for this graph. Here we may note that the vertex A is adjacent to the vertices B and C. So in the first row, we need to put 1 corresponding to B as well as C, and all the other entries will be 0 since they are not adjacent. Similarly, the vertex D is adjacent to vertex A and vertex D. So in the second row, the entry in the first column as well as the entry in the fourth column will be 0, and the remaining entries will be 0. So similarly, for all the other columns or rows also we can find, and the corresponding adjacency matrix is a 5 cross 5 matrix. In this matrix, we may note that the elements in the entries in the diagonal are 0. Since this is a simple graph, we may see that the diagonal entries will be 0, and since this is an undirected graph, the obtained adjacency matrix will be a symmetric matrix. We may find the sum of the entries in the first row is 2, the sum of the entries in the second row is 2, the sum of the entries in the third row is 2, the sum of the entries in fourth row is 3, and in the last row this is 1. So this is nothing but, the 2 is nothing but the number of edges incident with the vertex A. So first, the sum of the entries in the row represent the number of edges incident with the corresponding vertex. That is nothing but the degree of the vertex. So row sum is nothing but the degree of the corresponding vertex. Since this is a symmetric matrix, we also get the same value as the column sum also. So we may say that the row sum as well as the column sum will be the degree of the corresponding matrices. Next, let us see about the incidence matrix. Suppose we consider a graph with P vertices and Q edges, then a P cross Q matrix is said to be the incidence matrix of G if the entries are 1 Bij, that is 1 if the vertex Vi is incident with the vertex incident with the edge Ej, and 0 otherwise. Let us see one more example for this. Here we consider this graph. In this graph, we are having 5 vertices and 6 edges. Each row represent the vertices and each column represent the columns. Each column represent the edges. We may note that the vertex 1 is incident with the edge 1. Let us give the name for these edges. This is 1, this edge is 2, 3, 4, 5 and 6. So if we rename these edges with these numbers, we can say that the vertex A is incident with the edge 1 and 2. So in the first row we need to put 1 in the first and second column, and all the remaining entries will be 0. Now B is incident with 3 edges 1, 4 and 6. So corresponding columns 1, 4 and 6 only we need to put 1, and all the remaining entries will be 0. For the vertex C, it is incident with the vertices edges 2 and 3. So in the corresponding column we need to put 1, and the remaining remaining entries will be 0. For D, it is incident with 3, 4 and 5. So in 3, 4 and 5 we put 1 and the remaining entries are 0. Similarly for the vertex E, it is incident with 5 and 6. So we get a 5 cross 6 matrix, which is the incident matrix. In this graph also we can say that the number of sum of the entries in the first row is 2, the sum of entries in the second row is 3, sum of entries in the third row 2, for the fourth row 3, and for the last row it is 2. This represents the degree of the corresponding vertices, and since each edge is incident with exactly 2 vertices, we may find that the column sum will be equal to 2 for all the columns. I hope you understand the incidence matrix and the adjacency matrix for a given graph. Thank you.